Welcome guys, today we'll look at the short computational formulas to obtain the linear correlation coefficient R in statistics or biostatistics. How to use the product moment formula for solving or calculating simple correlation coefficient R. Correlation is the degree or strength of relationship between variables. Correlation seeks to determine how well a linear or other equation describes or explains the relationship between variables. When two variables are involved, as we have on our table here, we have x and y variables. We speak of simple correlation. However, when more than two variables are involved, we speak of multiple correlation. Now let's use the short computational formula to obtain the linear correlation coefficient for the data below. This is the short computational formula used to obtain the linear correlation coefficient R equal to n. N here means the sample size. We could get n by count. We have 1, 2, 3, 4, 5, 6, 7, 8. Going back to our formula, we could see summation xy. This simply means we are expected to create a row for xy. Xy means the product of x and y. 1 multiplied by 1, 3 multiplied by 2, 4 multiplied by 4, 16. 6 multiplied by 4, 8 multiplied by 5, 9 multiplied by 7, 11 multiplied by 8, lastly 14 multiplied by 9, 126. Now going back to our formula, we could see summation xy, meaning we are expected to sum up all the xy values, plus 6 plus 16 plus 24 plus 40 plus 63 plus 88 plus 126, 364. Going back to our formula, we could see summation x, meaning we're expected to sum up all the x values. 1 plus 3 plus 4 plus 6 plus 8 plus 9 plus 11 plus 14, 56. Going back to our formula, we could see summation y, meaning we're expected to sum up all the y values. 1 plus 2 plus 4 plus 4 plus 5 plus 7 plus 8 plus 9, 40. Looking at our formula, we could see summation x squared, meaning we're supposed to create a for s squared. S squared simply entails the square of each of the x values. 1 square, 1, 3 square, 9, 4 square, 6 square, 8 square, 9 square, 11 square, lastly 14 square, 196. Going back to our formula, we could see summation x squared, meaning we're expected to sum up all the s squared values. 1 plus 9 plus 16 plus 36 plus 64 plus 81 plus 121, lastly plus 196, 524. Going back to our formula, we could see summation x all square, and here is summation x. The value we got is 56, meaning we're expected to square 56, and that will give us summation x all square. And so 56 square, 3136. Going back to our formula, we could see summation y square. Now let's create a column for y square. Y square means the square of each of the y values. 1 square, 1, 2 square, 4 square, 4 square again, 5 square, 25, 7 square, 8 square, lastly 9 square, 81. Going back to our formula, we could see summation y square, meaning we're expected to sum up all the y square values. 1 plus 5 plus 16 plus 16 plus 25 plus 49 plus 64, lastly plus 81, 256. Going back to our formula, we could see summation y square, meaning we're expected to get the square of summation y value. Summation y value is 40. Square of 40 gives 1600. Now let's substitute all these values into our formula to obtain the correlation coefficient R. R equal n, our n value is 8, times summation xy, which we got 364, minus summation x, we got 56, times summation y, we got 40, divide by square root of n, times summation s square, 524, minus summation x square, 3136, n, times summation y square, 256, minus summation y r square, 1600. R equal to 8 times 364, 2912, minus 56 times 40, divide by square root of 8 times 524, 4192, minus 3136, times 8 times 256, 20048, minus 1600. 2912 minus 2240. 672. Divide by square root of 4192 minus 3136. 1056 times 2048 minus 1600. 448. 672 divided by square root of 1056 multiplied by 448. 473088. R is equal 672 divided by root 473088 is 687.8. So 672 divided by 687.8 equals 0.977. So we've been able to use the short computational formula to obtain the correlation coefficient R, which gave 0.977. Had to use the product moment formula for solving or calculating simple correlation coefficient R. Here we are expected to use the product moment formula to find or obtain the linear correlation coefficient between the variables x and y as presented in the table. This is the product moment formula for calculating coefficient of correlation R. Summation xy divided by square root of summation x squared multiplied by summation y squared, where x is equal to x minus x mean. So in place of x here, we'll write x minus x mean, where y is equal y minus y mean. So in place of y here, we'll write y minus y mean over square root of summation x squared. We did say that x is x minus x mean. So here we have summation x minus x mean squared multiplied by summation y squared. We also did say that y is y minus y mean. Now let's rearrange this table in vertical order. These are x variable here and our y variable here. Looking at the product moment formula, we have x, and we did say x means x minus x mean. This entails that we are expected to create a column for x minus x mean. In this table, x represents all the x values, while x mean represents the mean of x. We could see summation here. This entails that we are supposed to sum up all the x values. 1 plus 3 plus 4 plus 6 plus 8 plus 9 plus 11 plus 14, 56. We could also see mean x, meaning we're expected to calculate the mean of x value. Mean x will be equal 56 divided by 8. 8 represents the sample size. That is 1, 2, 3, 4, 5, 6, 7, 8, which is 7. Now let's fill up these spaces. First x value is 1 minus the mean value 7 minus 6. Next is 3 minus the mean value 4 minus the mean value 6 minus the mean value 8 minus 7, 9 minus 7, 11 minus 7, 14 minus the mean value. Looking at our formula, we could see y. We did say y entails y minus y mean. So meaning we're supposed to create a column for y minus y mean. Y here represents all the y values. And we could also see summation here. So let's sum up our y values. 1 plus 2 plus 4 plus 4 plus 5 plus 7 plus 8 plus 9, 40. Here we could see mean y, meaning we are supposed to get the mean of summation y, which is 40 divided by 8. Remember, we did say 8 is our sample size, and 40 divided by 8 is 5. Therefore, mean y is 5. Now let's fill up these spaces. First y value is 1. 1 minus y mean. Our y mean is 5. Next is 2 minus 5. 4 minus 5. 4 minus 5 again. 5 minus 5. 7 minus 5. 8 minus 5. 9 minus y mean 4. Looking at our formula, we could see xy. Xy means x multiplied by y. That is dx multiplied by dx. So we are expected to create a column for xy, which is equivalent to x minus x mean multiplied by y minus y mean. So first xy will be minus 6 times minus 4. We have 24 here. Minus 4 multiplied by minus 3. Negative 3 multiplied by negative 1. Positive 3. Minus 1 multiplied by minus 1. 1 times 0. 2 times 2. 4 times 3. 7 times 4. 28. Looking at our formula, we could see summation xy, meaning we're expected to sum up the xy column. 24 plus 12 plus 3 plus 1 plus 0 plus 4 plus 12 plus 28 equal 84. If you're getting value from this video, please give this video a thumbs up. And if you're yet to subscribe to my channel, please kindly subscribe. Thank you. So we've gotten our value for summation xy, which is 84 divided by square root of. Looking at our formula, we could see summation x squared. We already have our x column here, meaning that we are expected to create a column for x squared. The first x value is -6. Square of -6, square of -4, 16, square of -3, minus 1 square, 1 square, 2 square, 4 square, 16, 7 square, 49. Now looking at our formula, we could see summation x squared, meaning we are expected to sum up all the x squared values. 36 plus 16 plus dx plus dx plus dx plus dx plus dx plus 49 equal 132. So let's fix this value into our formula. Looking at our formula, we could see summation y squared. We already have our y column, meaning we are expected to create a column for y squared. So the first value will be -4 square, 16, -3 square, -1 square, -1 square again, 0 square, 2 square, 3 square, lastly 4 square, 16 here. Going back to our formula, we could see summation y squared, meaning we're expected to sum up all values. 16 plus 9 plus 1 plus dx plus dx plus dx plus this, lastly plus 16, 56 here. Now let's substitute this value into our formula. Equal 84 divided by square root of 132 times 56 gives 7392. 84 divided by square root of 7392, 0.977. 0.977 shows that there is a very high linear correlation between the variables x and y. I hope this video helps. If you really got value and yet to subscribe to my channel, please kindly hit the subscribe button and turn on the notification bell. Also do well to share this video with anyone who might find it useful. Comment with any questions or topics you would want us to cover in future videos. Give this video a thumbs up. Thanks so much for watching. See you in our next video. Bye.